So this question is coming from October number 20, paper 3 variant 1, and this is the 8th question of the paper. We are given a differential equation which we have to solve, and we are given the condition that x has to be positive, and when x equal to 1, y is equal to 1. We can utilize this condition to find the value of integration constant and eventually obtain an expression for y in terms of x. So over here, whenever we are solving a differential equation, there is only one technique that I've already explained to you during the key pointers video, that you separate the denominator of the derivative term and keep it to the right side. Basically send it to the other side of where the derivative term is present. So in this case, it means that I'll keep my y terms on the left side and the x terms on the right side. So in that process, this y will go to the left side and this x and dx will go to the right side. So if I try to simplify this, it will look like 1 over y dy is equals to 1 minus 2x square over x dx. Now the second step would be to integrate on both the sides, on the left with respect to y, on the right with respect to x. So what is the integration of 1 over y? It is ln y. Now you might ask, can we add a constant over here? Of course, if you want, you can add it. But then let's say there is a constant over here also. So when there are two constants, you can always take two constants and club it into one. You can call C2 minus C1 as one constant on the right side. So you don't need to show both the constants. You can just have one integration constant during your integration on both the sides. So I'll keep my integration constant on the right hand side, which will be the combination of the constants on each side. But yeah, we don't really care. We just need to have one integration constant. On either side, you can have it. Now, how about this term? How can we integrate this? So if I try to simplify the fraction, it's going to look like 1 over x dx, and then minus 2 times this x, and this x will get cut. So I'll have integration of x dx. All right. So I can go ahead and say that ln of modulus of y is equals to ln of modulus of x minus 2 times x square over 2. So the 2 gets cancelled out and I'll be having x square. And now I can have one integration constant. Okay, so of course you were having an integration constant over here, here and here. You are clubbing that all into this one. And now we can find the value of this integration constant by substituting your values of x equal to 1 and y equal to 1. So substitute x equal to 1, y equal to 1 to of course find the value of c. So ln of 1 and ln of 1 over here will become 0, and you will be having c is equal to x square. So your c will be simply equal to x square, which is equal to 1 square. So your c value is equal to 1. So therefore you are having your differential equation which you have solved over here. You can call the solution of differential equation is as follows: ln of modulus of y is equal to ln of modulus of x minus x square plus 1. Now in the question, it was mentioned that you have to make y the subject. So in that case, what I can do over here, I can simply take e as the base on both the sides so that e and ln gets resolved and you will have y on the left hand side. Therefore, your answer over here will become y is equal to e to the power of ln of modulus of x. Now you can convert the modulus to simply x because you know that x is greater than 0. So modulus is not required. It is only required for the negative values because ln cannot take the negative value. So ln x minus x square plus 1. Everything is in the power. Now if you want, you can go ahead and simplify it further because I know that it can be written in the format of e to the power of ln x times e to the power of minus x square plus 1. The only reason for doing this is because I know that I can simplify it further. I am doing this. Whenever the question says that you need to simplify as much as possible, you always do that. But even when it's not mentioned, it is really a good practice to simplify as much as possible so that later on when you are solving the questions where in the question it demands you to simplify, you are not like, you are completely clueless that I don't know how to simplify it further. So that is why I always recommend that you simplify always, even if it's not mentioned in the question, at least during your practice. In the examination, you can leave your answer over here if you like, but yeah, I'll recommend that you always simplify as much as possible. So after this, I know that e to the power of ln x can be written simply as x, and yeah, I can conclude my answer that y is equal to x times e to the power of 1 minus x squared. You always open your marking scheme and check if your answer is matching your marking scheme or not. If not, try to go ahead one step and see if you're able to get that format.